All right, here we go. Second semester. Woo! Got a short chapter to kick it off with triangle properties. So let's get started. So the next few days, we're just going to be talking about different properties of triangles. Some of the stuff is going to make, actually, it's all probably going to make sense. You just might hear some terms that are neat, that sound new. First thing we're going to talk about is the triangle inequality theorem. And that sounds really complicated, but what it says is to be a triangle, the sum of any two sides must be greater than the remaining side. Okay. So to say it differently, the longest side, that little star, the longest side of a triangle is never greater than or equal to the sum of the other two sides. Cool. Okay. So the longest side always has to be smaller than the sum of the other two sides, of the two smaller sides. And we'll go through a couple of examples. Oh, I'm using my black, that's a little easier to see. So examples, we're going to go through triangle or not. And these are what some of your problems are going to ask you to find. So number one, if you're given 3, 5, and 9, could those form a triangle? Well, we're going to add the two smaller sides. 3 and 5 make 8. 8, the last side's bigger than the sum, so this is not a triangle. And the reason for that is if we had to kind of draw this, we'd have like a 3 side, a 5 side, and a 9 side. Well, clearly you can't manipulate that such that you actually get a triangle because this other side is just too big. Number 2, what about 4, 8, and 8? Well, we're going to add our smallest two sides. I mean, we have 2 8s, so you can really pick whichever one you want. 12 is bigger than 8, so we are good to go. Hey, that'd be an isosceles, wouldn't it? Two sides of the same. What about 7, 7, 7? Cha-ching. Same process, add the smallest two sides, 14, and it is able to be a triangle because the sum is bigger than the leftover side. And that would actually be a, what's it called? Equilateral. All sides are the same. What about this guy though? 8, 8, and 16. What would happen here? I'll zoom in a little bit so you guys can see better. Well, I have my two smallest sides and I get 16. Is this okay? No. I have to be bigger. Okay? The sum must be bigger than the last side. The reason for that is if the sum is exactly equal to the third side, you wouldn't have a triangle, you'd have a straight line, and that's not a triangle. Okay? Now the second piece you're going to use this property for is to find the range of a side. Remember, a range of values is like anything between 5 and 10 would work, something like that. So we're going to talk about finding a range of values. Finding the range of values. So finding the range of values, it could be something like, actually I'll just pick a couple here, something like this. Side 1 equals 1 centimeter. Side 2 equals 6 centimeters. Find side 3. Okay. And remember the property. The property is the longest side can never be bigger than the sum of these two other sides. Okay? Well, if we add these two guys together, you get 7. And if we subtract the two numbers, we get 5. That's actually how we're going to figure out a number that would work for this. So we go like this. We set it up like this. Kind of, this is your x, a number less than x, which is less than another number. And here you subtract the two numbers, and here you add. So that's kind of how to work the formula here. So if we did 6 minus 1, we get 5. And here we do 6 plus 1, we get 7. Boom, there we go. In our last guy, number 6, we're going to apply this little formula with a 12 yards and 18 yards. I'm going to kind of write the pattern. And remember, we subtract for the first guy. 18 minus 12 is 6. Always do your smallest number by your biggest number. You do not want a negative in here. Negatives with distance just don't work. And then we add for this one. Now the reason why this works is because what you're saying with the lowest point is saying, hey, the lowest side plus this value is still going to be bigger than 18. And you might be like, well, Mr. Magnuson, hold on. 12 plus 6 is 18. That doesn't work. I'd say you're right. And that's why we use a greater than symbol, not greater than or equal to. So x can be anything bigger than 6, like a 6.1, because technically 6.1 plus 12 would be 18.1, and that would be bigger than our 18. This guy is, if this was the hypotenuse, which would mean we add these two guys together to get 30, and this number can be anything less than 30, like 29. Why is that? Because if this guy's 29, that's our biggest side, and 12 plus 18 is 30, so 29 would be less than 30. So anything between 6 and 30 would work to find the range of the values of a third side. And we're going to add that to the notes. Finding the range of the values for a third side. I should really have included that at the start, but you know what? We can adjust our notes and get better as we go. So, that's it. And I'm going to do just a few examples, so you can check out that video next if you like. Thanks for watching.